Good afternoon, everybody, and welcome to another Geo-Institute live stream. My name is Brad Keeler. I'm the director of the Geo-Institute, and you may be wondering what that tree is behind me. I will talk about that in just a second here. The first thing we have to do is say that we are definitely thinking about all of our colleagues and friends that are in the Southeast this week and this weekend, and hoping that everybody makes it through Ian okay, and that we see you on the other side. With that out of the way, let's get started for today. First things that I will say are this. This is, of course, hosted by the Geo-Institute. If you don't know anything about the Geo-Institute, after you watch this today, you should head over to geoinstitute.org, and there you will find out that we are a technical society with about 12,000 members, most of whom are geotechnical engineers and/or geologists. And we are part of the American Society of Civil Engineers. If you like what you see today, and I think you will, you should do a few things. You should click subscribe, you should click get notifications. You can even give us a like if you would like under the video. And if you do those things in that order, we will let you know every time we post something to the YouTube channel. Couple of things that are coming up. Next Monday is Terzagi Day. If you do not know this, every year on or around Carl Terzagi's birthday, we celebrate with a variety of things. One is the Terzagi tree, which you can see beautifully displayed in my sunroom right here, with ornaments highlighting Terzagi's career and past Terzagi lecturers. We also have a live stream on Monday where our guest will be from the Norwegian Geotechnical Institute, Suzanne Lacasse, also the 2001 Terzagi lecturer. So she'll be talking a little bit about Carl Terzagi's legacy and what he meant to her career, and about the Terzagi library that is at NGI. We also have Carl Terzagi bobbleheads. If you would like to support GI student programs, and I know many of you may wish to do that, you can join the 96 Club and get one of these bobbleheads for $96. Just click on the link on the website that says Student Participation Fund, and we will guide you the rest of the way through. That's going to be about it for me today. I'm going to turn it over to our all-star moderator and our two people a panel. We will call you a mini panel. Our mini panel who are here to talk about NAVFAC DM 7.1 today. We're excited about it. It's good to see so many people watching. Thanks for joining us. And our moderator today is Andrea Welker from the College of New Jersey, where she serves as Dean of the Engineering School. Andrea, take it away.
Thank you so much, Brad. I'm really excited about this today. I use DM7 quite a bit in the past, so I'm just so excited to hear about the changes. And we have two folks here to help walk us through it. And the first person I'm going to introduce is Joe Woliver. He began his career with the Naval Facilities Engineering Systems Command in 1998. As the Chief Geotechnical Engineer for NAVFAC, he serves as the command's technical authority on all geotechnical and pavement engineering matters. Joe provides oversight and management of geotechnical engineering discipline within NAVFAC, helps develop and disseminate policy, guidance, findings, and processes related to geotechnical engineering. He leads a team of civil and geotechnical engineers which design, construct, and maintain the Department of Defense shore facilities. Joe maintains two enterprise-level programs for the Navy, the NAVFAC CB Design Program and the NAVFAC Airfield Pavement Evaluation Program. Joe also develops and maintains design and construction criteria for DoD airfields. Our other panelist today, or mini panelist as Brad described it, is Daniel R. VandenBerge. He has 19 years of experience in geotechnical consulting and academia. After obtaining his BS and MS from Michigan Tech, he started his career at EDP Consultants in the Cleveland, Ohio area. From there, he moved to Virginia Tech in 2010 to work on his PhD. Dan is an associate professor in the Civil and Environmental Engineering program at Tennessee Tech, where he's been leading the geotechnical program area since 2015. He teaches courses in geotechnical engineering, foundation engineering, slope stability, seepage, advanced soil mechanics, and probabilistic methods in civil engineering. Dan's research interests include soil shear strength and consolidation, slope stability and seepage analysis, probabilistic design, and engineering education. He has published 60 technical publications on these very topics. He is currently leading a team on the revision and expansion of NAVFAC DM 7.2. So I'm going to turn it over to our mini panel now to get this thing kicked off.
Hey, everybody. First, I'd like to thank ASCE and the Geo-Institute for setting this up for us, and thank everybody for attending today's live stream. As Dr. Welker said, I'm Joe Woliver. I'm NAVFAC's Chief Geotechnical Engineer. I'm going to run through the somewhat administrative side of updating the manual, the people involved, and then hand it back over to Dr. VandenBerge, and he'll go through the technical side of the update. So, first slide. So on the right side, these are the DoD proponents. On the right side of the slide, we have the DoD Geotechnical Discipline Working Group. The function of these working groups are to develop and maintain the criteria for the Department of Defense. There's approximately 24 of them. They represent the different disciplines necessary to design and for design and construction of DoD facilities. They're led by the coordinating panel and the engineering senior executive panel. We call that the Esep panel. The Esep panel consists of the chief engineers for all the services, like Army Corps of Engineers, NAVFAC, APCAC, which is Air Force Civil Engineering Center, Air Force. So, and the Office of Secretary of Defense is also on that panel. They ultimately sign off on the criteria manuals that we produce. The current service representatives of the Geotechnical DWG are Dr. Georgette Helpus, and she's a chairman, and Dr. Charles Ishii for the Air Force, and Jeff Singer for the Navy. And the light gray, I've listed the former members of the panel. This was a long effort to get this first manual out. Dr. Robert Dinan for AFCAC, Dr. Rick Olson from USACE, and James Sauceda from USACE. I also forgot to add two people, Vanessa Bateman and David Rediger, who also contributed to the effort. So NAVFAC requested the funding to update the manual, so therefore we managed the effort. The people that did the heavy lifting for NAVFAC and got the effort off the ground were Kristen Brennan and Jeff Singer. They were both in my office at the time. Kristen's moved on to criteria right now, and Jeff is my deputy chief geotechnical engineer. They've managed the project, did the scopes of work, estimates, worked with contracts to award the project, set up the reviews, and kept the project rolling. So, next slide. Let's see if I can get my next slide. So, the progression of the document. I won't go too far into the history of the DM series, but the design manual we know today come from, at least in part, from the government laboratories like Waterworks Experiment Station, which is now ERDIC, Engineering Research and Development Command for Army Corps, Naval Civil Engineering Laboratory, which is now NAVFAC, XWIC, Cold Regions, Corel, Bureau of Reclamation, Federal Highways. They were all doing research to construct things like canals, levees, dry docks, airfields, highways, and they're still producing research on various subjects. So the first predecessor to the DM7 series was published in 1953, and it was turned into a series in 1962. Bureau of Yards and Docks was the predecessor to NAVFAC. Put a design manual series together in 62. They were part of a 26-volume set of design manuals. These manuals covered all engineering disciplines and also covered specialties like ship moorings, airfield pavements. And there were subsequent updates of the DM7 manuals until 1986. And then the DM 7.3 was converted to a mill handbook. We've kind of gone through a lot of different iterations with design manuals. All services had their own. So it became a little chaotic with all the manuals. So the last, it was converted to a mill handbook in 1997, and then it was updated one last time in 2006. The 2005 version of DM7.1, which was UFC 322010N, was a revalidated 1986 version of the DM with the UFC cover. The reason was primarily just lack of funding, more than anything, of producing these manuals. They take a lot of time and effort. So in the late 90s, 97, 98, Congress mandated the creation of unified facilities criteria. And they were a different animal entirely from the design manual series. They were intended to hold DoD criteria for constructing facilities and only the criteria. And they wanted to reduce the number of design manuals and guidance being produced by the services and adopt commercial standards where we could. In that way, they could reference the UFCs directly in contracts and in hopes of faster execution and shorter construction duration using design, build, and other procurement methods. That's why you see some of the rather short UFCs. Those are usually based on a commercial standard or an additive or subtracted document referencing a code. UFC 322001, geotechnical engineering is an example of that type of UFC based on the IBC. So next slide. So the timeline, the tri-service goal for DM7 was to get the manual breathing again, make it legible and usable, move the document forward, maintain the document's integrity, and renovate the technical information of the document. We also wanted to keep it both relevant to the practicing engineer and be able to support our military engineering groups like the CBs, Red Horse, Army Corps, Marine Heavy Combat Engineers, and even some of their air wings that provide expeditionary construction. The process was kind of akin to restoring a historical house. You kind of have to evaluate the structure, remove the bad, carefully restore the good. And given the prominence of the design manual in practice, we didn't want to destroy something that so many people still reference. So in order to do that, we started in 2015 and we approached the update in two phases. The first phase was an academic review. We wanted to determine what content was still relevant and what could be replaced. We also had to get an idea of the level of effort that was going to be needed for phase two, such as redrawing useful figures and nomographs. And we also had to investigate copyright impacts because they had changed over the years. The second phase, of course, was gathering a team to get the content together, write content, reproduce graphs, data charts. And in total, it took us 6 years for this manual. But we've been able to cut that revision time down to 18 months now. So next slide. So the current status, we have a fully updated design manual that can be easily updated from this time forward. All the charts, tables, and graphs are in a form that can be updated using computers this time. You can actually read the nomographs now. They're not, the lines aren't 3 inches wide after they've been reproduced several times. So you can actually read everything now. It's now a tri-service UFC, so all services take responsibility and updating it. UFC 3220-10 is its title. It doesn't exactly roll off the tongue, but we'll keep the parenthetical DM71 so that people can find it. In fact, almost every year, someone sends usually a snail mail letter to our admiral requesting a copy of DM71 or 72, and it actually makes it to Admiral Vanderlei or Admiral Aguayo. And so nobody has to do that anymore. The manual can be downloaded for free. You don't have to go to any reprint companies. You just go to the whole building design guide. There is a QR code on the page. It's a legit QR code, and it's no Rick Astley videos or anything, I promise. And when you go to that, it takes you to the download page for the document. It's 45 megabytes, so I didn't link directly to the document in case somebody's looking at using a phone or something like that. The link is near the middle of the page, and just below the download link, you can see what's called the CCR link. It's criteria change request. That link will allow you to enter comments to the document, whether it be a typo or error or suggestions you'd like us to consider for the future versions. We do read and evaluate the comments, so please feel free to do so. So before I turn it over to Dr. VandenBerge, I would like to also add I'm a member of the Government Engineers Council for ASCE. So we hope to have more things like this manual to present in the future, something that brings value to both public and private service. We hope that the DM will remain a valuable part of geotechnical engineering profession, and that engineers will find it useful in their career. So I'll throw it over to Dr. VandenBerge, and he'll dig into the details of the new DM.
Okay, thank you, Joe. As Joe said and Dr. Welker said, my name is Dan VandenBerge. I'm an associate professor at Tennessee Tech, and I had the great privilege to work on this project over the last few years. I'm also thankful to ASCE for providing this opportunity to speak to you all and to present about what we did on DM 7.1. So I was the co-PI on this project. The lead was Dr. Tom Brandon at Virginia Tech. He was the one who performed the academic review and really gathered the team together. Also, other major authors were Dr. Bernardo Castellanos at Virginia Tech, Dr. Bob Bacchus from Geosyntech, and Dr. John Rice from Utah State. Some of the other contributors included Rick Valentine, helped us with some of the content, and then I had a number of graduate students that helped with many of the figures, as well as some of the late editing in the process that we just wanted to acknowledge for all their hard work on the project. So one of the first things that the author team had to do, and a lot of this happened actually in that first academic review phase, was to think about what is important for us to keep, what is important for us to change. And so that was done through sort of a strength and weakness comparison. So looking at the existing DM 7.2, or the prior version rather, some of the strengths were that this document has been used by engineers within the Navy and throughout the world by practitioners and academics, and has a really broad name recognition that we want to be able to preserve and hopefully enhance. It has a long legacy of being a useful document for correlations and as well as certainly valuable figures that you may know of, that NAVFAC is really the place where those have resided over the last many decades. And in certain figures are cited in just about every geotechnical textbook. And again, so we didn't want to destroy that sort of legacy. The document also was a really good example of how to use figures and tables well to summarize information, to summarize analysis procedures. And again, we wanted to preserve that. And it provided a good place to go for some additional references, and we wanted to kind of enhance that that property. Some of the weaknesses Joe has already spoken on, but I'll reiterate. Really had a lack of meaningful updates since that 1970s version. That had led to a pretty antiquated appearance. The document was pre-internet, really pre-personal computer. So most of the figures had kind of deteriorated over time. There was also many outdated references, and we had some changes to copyright and permissions, at least practices, since 1986 that we had to think about as we move forward. So the figures really needed to be redrawn to be legible, to not be just a photocopied version from the past. And there was also a bit of non-standard incorporation of references into the text. So it was very hit or miss whether you could figure out where a piece of information had come from in terms of citation. And then we hope to update that, and I think have accomplished that. Occasionally there were some typos, especially related to equations and past optical character recognition that we needed to figure out and then and to modify and update. And then finally, we did identify some design procedures that maybe weren't quite applicable to that target audience. So what I'm going to do now is do a very broad overview. This is more of a 30,000-foot kind of view of the document and some of the changes that were made, things that were added, things that were modified. And after this slide, we'll go through chapter by chapter and do that. One of the things I wanted to point out from the forefront, though, is there were some things that we did every single time that we'll mention here, and helpfully to accomplish some of addressing some of those weaknesses. So some of the things that we added or changed in every single chapter, where we added a suggested reading. So this is akin to what really the reference section in the old DM 7.1 was more like. It was really documents that would help you dive further into a given topic. So we've maintained that, updated that with some good references for each particular section. We also added a list of notation by chapter, recognizing that even from chapter to chapter, there's some differences in how notation is used. And so we want to make that clear within the document. We did provide a comprehensive list of citations wherever is appropriate in the text. So you see the citation level is closer to a textbook or even a journal article than it was in the past. And then the document does have a full reference list at the end as well. And then finally, clarifying the equations. We no longer have text-based graphic equations, but equation editor type equations. And then finally, we completely redid all of the tables and figures. I'll be showing you examples of these as we go on through the rest of the slides. But we were able to, or really needed to, of course, get rid of the text-based tables, which many of you, I'm sure, are familiar with. We didn't necessarily change the content in every case, though many times we did update or edit the content slightly. But we got rid of the old text-based table format and moved to a more modern word processed format. So going through the various chapters, I'm just going to go through chapters 1 through 8. Chapter 1's on identification and classification of soil and rock. So here we updated and expanded the sections on soil classification, made sure we were in line with current USCS in terms of ASTM classification. Also updated the sections on rock classification based on RQD, strength, etc. And updated sections on special materials. So there's some short sections on materials such as collapsing soils or expansive soils or karst materials. So if you're kind of looking for a start understanding one of those topics, you could turn to chapter 1 there. Along the way, as part of that, of course, as I've said, we had to update figures. This is an example of how that update process went. At the top on the right, you'll see an old version of the Casa Grande figure from DM 7.1 that has a super useful amount of information in it. So it shows how properties change as plasticity index or liquid limit increases. And we wanted to maintain that, but of course needed it in a new crisp format. So this is a case where we simply redrew and replotted the figure, trying to stay faithful to what it was in the past. Some of the things we've added to chapter 1, our ASCE classification was not in the original and is a still common and useful approach. We've added a long list, a few pages long, of colloquial soil terms. So for example, buckshot clay. If you're not from Louisiana area, you may not know what that refers to. And so there's a list of that sort of terminology in chapter 1 to help you kind of get through those regional differences you might see in geotechnical engineering. And finally, we added some additional classification based on rock mass, based on, or we talk about the Q system, the RMR system, as well as GSI. Moving on to Chapter 2. This chapter is on field exploration, testing, and instrumentation. In this case, we updated and expanded the sections on field reconnaissance, remote sensing, geophysics. Many things have changed in the last few decades in those areas due to technology, to the availability of materials on the internet, and we felt the need to explain some of those in more detail. I will say one side note here, since I just mentioned the internet. We did our best to actually keep URLs out of the document because we didn't want links becoming dead with time. So we will tend to refer to locations or possibly types of websites, but we tried to refrain from specific URLs throughout the document, and that was an intentional decision we made. Chapter 2 also has updated guidance on drilling and sampling methods, as well as on instrumentation. That's another area where there's been much change in the last decades on the types and availability of geotechnical instrumentation. There's an added section in Chapter 2 on offshore sampling, as well as an updated examples of modern reporting techniques. So, for example, the boring log that's shown here is what you would expect to see in 2022 for a geotechnical boring log, as opposed to what was in the original document. One of the things that we also saw in Chapter 2 as a need was some concise summary figures for many of the field testing procedures. You may be familiar with some of the old figures from the original DM 7.1 that are relatively famous, especially for SPT. So these are updates that are pretty dense figures that show various configurations of equipment, some of the equations involved, the process involved in these tests. And much of this was modeled after some of the NCHRP and documents by Maine that are available. So we're pretty happy with how these figures turned out, and the amount of information that can be conveyed in these nice half-page figures. Moving on to Chapter 3. This is on a chapter on laboratory testing. So we updated and expanded various parts of this. There's a large table, I think it's a few pages long in the new document, of how much sample size you need for any given or common geotechnical laboratory test. There's also an updated or expanded version or discussion of the standards and certification process, so people can understand how that works a little bit more. There's a table of index properties and parameters that's provided in this case, and there's quite a bit of detail on compaction tests. There's a nice one-page figure that some of the academics may be thinking, I need to get that for my graduate students, or sorry, for my students rather. Nice supplement to all the different weight volume relationships that we face in geotechnical engineering. Chapter 3 also talks about at length about strength tests. So it discusses direct and ring shear tests. It discusses consolidated drained and undrained triaxial tests, along with UU triaxial tests. It discusses unconfined compression, direct simple shear, lab mini vein shear test, as well as various dynamic testing methods. Most of the test methods contain at least one figure showing both the apparatus as well as some of the data or results that you would expect to come from that test. In addition, there's discussion of both incremental and CRS consolidation testing. There's discussion of hydraulic conductivity testing, as well as some basic rock strength testing. Chapter 4 looks at the distribution of stresses. So we've updated and expanded the sections on stress calculations, change in stress equations. This is a place where probably many of us grew up using some of the NAVFAC charts and tables. So we've got a nice table that it focuses on many of the equations required for different types of change in vertical stress for different loads. We've also updated all of the change in stress charts, which we'll see a couple examples on the next slide. And we've got some good example problems. So you could really spend some time looking at how we reach the solutions that are in these various example problems. One thing that's been added to Chapter 4 is a few pages of discussion on numerical solutions for stress, recognizing with personal computing power that we have, much of this does happen at the computing level. So we talk about linear elastic as well as nonlinear elastic numerical solutions for calculating stresses and changes in stress in the ground. A couple of the iconic charts, I think, from NAVFAC are shown on this slide. We recognize the value that these have both for teaching aids as well as for important checks to computer solutions, or just for cases where you're not near your computer. We wanted to maintain and enhance the usefulness of these charts as well as some others that are included in the document. Moving on to Chapter 5. This chapter deals with the analysis of settlement and volume expansion. This chapter was less so added to, but more reorganized and expanded. It starts off with a mechanics of consolidation discussion, going into a little bit of depth about what is going on in the soil during consolidation. And then when we move into the calculation of settlement, really focuses on how settlement can be understood as strain. And so as shown in the upper right, we took care to connect the dots, so to speak, between the more conventional void ratio log stress type relationship and the strain type relationship, which really helps to engineers to understand how those settlement equations really work. From there, we move into settlement of coarse grain soils, looking at a variety of empirical methods, and then settlement of fine grain soils using conventional consolidation theory. There's also quite a bit of time spent on time rate calculations. So we've updated the degree of consolidation versus time factor chart as shown at the bottom right, including some of the equations that can be used in lieu of the chart solution. And also a variety of updated figures on vertical drains and radial consolidation, and a summary of volume expansion methods. In the volume expansion case, there's quite a few different empirical formulas out there. And so what we did was summarize the inputs that are required for those various formulas. So someone can know, hey, I've got these two known properties, which methods could I use to estimate volume expansion? On Chapter 5, we've also added a few things. We added a summary of C sub C correlations, particularly looking using the figure at the upper right, looking at how those correlations really tell a similar story. And so if you plot the C sub C correlations versus initial void ratio, you see a pretty consistent trend predicted by a wide variety of correlations. And so we've tried to do that in a number of places through the document, kind of consolidate the known relationships into a more coherent whole. There's also a new section on hydrocompression and some expanded information on angular distortion limits, including this figure at the bottom left from based on Berland and Burbridge's work. Moving on to Chapter 6. This chapter is on seepage and drainage. On here, we've expanded and updated the discussion of the mechanics of seepage. So again, going into a little more depth at the beginning of what's going on from the mechanics standpoint with seepage. Then we moved into guidance on flow nets, recognizing that flow nets are not really likely to go away anytime soon. They're still a useful and needed check to many of our numerical or other schemes for calculating seepage. And then also added and updated the discussion of internal erosion, which again is a topic that has really evolved and changed a lot in the last few decades. We added extended discussion of numerical analysis of seepage, since that is probably the primary types of seepage analysis. Sorry for that interruption. And we also had various methods of determining hydraulic conductivity that are discussed in this chapter. Then we also added a mineral and geotextile filter criteria, providing the FEMA documents or the FEMA guidelines for designing filters. There's a nice step-by-step process for that within the document as well. Moving on to Chapter 7. Chapter 7 was also expanded and updated, looking at its discussion of limit equilibrium methods. Again, this is slope stability, doing some comparison of the different types of limit equilibrium methods as shown at the right, anywhere from simple free bodies like the infinite slope analysis through wedge analysis to various methods of splices. So detailing those at various levels. Also discussed at some length finite element and finite difference methods for slope stability. The document also updates the use of water pressure effects within slope stability analysis, has a really nice discussion of analysis cases. So what to do in various cases, which types of analyses to run, drained, undrained, etc. And then also some discussion in a figure table format of slope stabilization. Things that were added were a clearer definition of factor safety. That was really not very clear in that first, or in the original DM 7.1, how factor safety was being defined for slope stability. And again, some guidance for different types of stability analysis. We also added discussion of reinforced slopes and rock slope stability to Chapter 7. Chapter 8 is a brand new chapter. This was not in the original document. So the topics in Chapter 8 the correlations in Chapter 8 are organized by topic. And so they start out talking about effective shear strength. So it looks at effective stress shear strength correlations for coarse grain materials and then for fine grain materials. And then even more detailed than that, looks at different sources of information. So based on blow count or based on other types of properties. So of course we updated the figure at the upper right, which is another iconic DM 7.1 figure for the relationship between unit weight or void ratio and friction angle for various types and relative densities of coarse grain soils. There's also quite a few correlations for undrained shear strength provided, a wide variety of consolidation parameters and elastic parameters, and then some discussion of correlations for CBR, for hydraulic conductivity, and for shear wave velocity. The lower right shows an example of again, some of the consolidation, so to speak, of correlations that we did So there's a few pages of correlations for compression index based on various index properties. And rather than plotting all of those, we decided it would be useful to plot some of these ourselves and then define the band of relationship that are predicted by these many correlations. And what this does is it just gives you a feel for what this property should be with respect to the property on the x-axis of the plot. So this one is just an example of some other plots that are included in Chapter 8. And then finally, moving on to the end matter. So the document has references, of course, at the end. It has a long list of computer programs, which were up to date as of about 2 years ago. I'm sure they will continue to need to be updated. It has a long list as well of geotechnical symbols, recognizing that sometimes we don't always do a good job of using the same symbol for consistently across the profession. So we've tried to summarize that well, both from within the document and more broadly in that table. And then there's again a glossary in this document as well. So in summary, I believe our team has produced a great resource for the geotechnical community, first and foremost for our DoD and other government agencies to use. But we know that practitioners use this. We know that academics use this, and we believe it's a great resource for everyone to share. We also believe that we've been able to preserve that legacy feel, but in an up-to-date format. So we hopefully have been sensitive to doing that well. And then finally, just want to promote geotechnical practice through what we believe is a summary of the state of the practice methods within geotechnical engineering. So now I just want to, again, thank you for your time. Again, we've got the QR code here and the website in case you didn't catch that sooner or earlier. So I think now we'll stop the presentation and come back for questions.
All right, well, Dan and Joe, thank you so much for that. And we do have some questions rolling in, which is super exciting. So the first question is from Pablo in New York City. He asks, first of all, apologies if I missed this during the intro, but is a similar update being performed on DM 7.2?
Yes, there is. It's actually, and I'll just talk a little bit about it and throw it over to Dr. VandenBerge. It is at the 95% stage right now, and it will probably be released in the spring of next year. So if Dr. VandenBerge, if you want to talk a little bit about it.
Sure. So yeah, I mean, that's pretty much it. We just submitted for review external to our author team just a few weeks ago. So we're in that process of revisions this fall and into the spring, and yeah, with hopes of getting it out in the coming year. So
Great. All right, so I have another question for you. Matt says, thank you for all the effort that you put in, and he's found it really easy to use, but he did find a mistake, a typo. How can that be reported?
Should I can show the website if you want, Joe.
Oh, sure. Yeah. Go ahead.
Let me pull that up, and that's probably the easiest thing. So I'm gonna, let's see, come back here. Let me escape out of that. And so if you were to follow that link that we provided, it would get you to this page right here. And if you scroll down right here, it says criteria change request. And I believe you click that link and it takes you to the spot you need, right, Joe?
Yes, that is correct.
Okay. Excellent. All right, so another question is, have you, or does this deal at all with unsaturated soil mechanics?
I'm thinking. To some extent, yes, in terms of, of course, some of the volume expansion methods and other methods like that have unsaturated soil mechanics that are affecting them. It does not delve into the details of, say, unsaturated soil mechanic theory, though.
Okay, so another one here is there any direction for how to assess corrosion?
Corrosion. Any more specifics? I think corrosion, I mean, to some extent would be more of a DM 7.2 topic. If you're thinking of corrosion of sheet pile or something like that, I believe there will be some discussion in there, though I shouldn't promise that. I'd have to try to remember. There may be something in chapter 1. I can search a minute. There's a lot of pages here. So.
There's a lot of pages, yeah. All right, so while you're doing that, I'm going to ask another question about 7.2. Will that update include changes to how to include down drag in pile design?
Yes.
All right, I like a straightforward answer. You're just like, yes.
That I know. There is some discussion in chapter 1 on chemically reactive soils. It's not it's a page or so, but points out some other resources. I think when it comes to corrosion.
Okay, great. What would you say is the most important addition that this has made?
Do you have a perspective on that, Joe? From the outside? I mean, I'm going to be biased, I think.
Well, I mean, I'm just happy the thing is breathing again, so it's usable. So, everything is good from my perspective.
I think probably, and it's really along the same lines as what Joe said, the resurrection of figures that are kind of deteriorating over time, I think is probably one of the more important things. And I think just keeping in front of people that just because we can do things with computers, we still need these figures for verification of solutions and things like that, as well as teaching for those of us who are academics.
Great. So a follow on to that, perhaps, is that are there any graphs or equations or even discussion in the original document that you found to be out of date, inaccurate, or just wrong, and that you would say don't use that anymore?
There is an update, and so that at least I was told. I'm not sure if I ever actually verified this for myself, that that the rectangular area stress distribution chart was previously incorrect, and that we are sure it's correct now, and so that you could actually enter it using two different, switching the direction of your X and Y axis and get two different answers, and so that is a case where I think the old was incorrect and the new should be correct. Anything that was outdated, the harder part is it's been 4 or 5 years since we're looking at that part of. So I know what the new stuff is. Trying to think if there's any. So the question was about the old one, right?
Mm-hmm.
What not to use? Ooh.
Just use the new one.
Yeah. Use the new one.
Use the new.
That's a good answer. Yeah. I should have said that first.
Yeah. All right. So Natalie notes that the new figures are really great, but she has noticed that some of them are pixelated. Were images vector formatted and then lost resolution and conversion to PDF, and any thought about digitizing or providing the spreadsheets that were used to create the charts?
Yeah, we tried to generate things in the highest quality format we could, but do recognize that sometimes things do lose that quality. There's a balance there between the size of the document and the resolution of the figures. Some of the original figures that we generated in early drafts, a single figure might be 20 megabytes, and of course compresses in the PDF. But so we did our best in that regard. In terms of providing figures or spreadsheets, to some extent that's difficult. If there's real need, I believe that the Navy is willing to use that CCR request as a mechanism if they have to get a figure out to someone.
All right, so what was the hardest part about doing this?
I think personally the hardest part was the fact that we only had those old PDFs, or possibly some of us had paper form as the source material. And there, as you know, are a large amount of complex figures, as we're just talking about. In addition to that, the old document was not well cited. It had those references which were really helpful for more reading, but when you want to figure out where a particular figure came from, it was not there. And so it took a lot of searching to find the original documents so that we could replot and update the figures. And our goal, and I think we achieved it to the most extent, was whenever we knew there was theory behind a figure, we wanted to plot it based on the theory, not based on tracing. And so that some of the figures represent our weeks of effort on the part of students and/or authors. So those are the major challenges, I think.
Joe, do you have anything to add to that?
My challenges were all on getting the thing off the ground, getting the funding for it. I had to wear down one of our criteria directors to eventually get us the funding to do it. A lot of it was just getting them to understand the importance of the document to the profession. So we finally did get through, and the rest is history. They got the funding and moved along. So that was a difficult part for us.
All right, so I'm going to ask a far more positive question. So what was the best part about working on this?
You want to go first this time, Joe? Or no?
No,
I can.
Best part. Well, I mean, Kristen and Jeff did all the heavy lifting on this, so I was kind of external to the process. I'm kind of at the 40,000 foot level. So I'm sure they've got some favorite times. I think they would probably say working with the team and getting things moving. I think they really enjoy the interaction with the authors and setting everything up. So I think that's what they would say.
I think on my end, I mean, it honestly kind of goes with that. Goes with the challenges. The things that made it challenging were also honestly what made it fun. We got to dig into things that you'd almost taken for granted, and got to see where it came from. Sometimes it's searching a source back, and then that goes back, and you're searching back 3, 4, 5 layers before you find the place that it first showed up. And that was kind of like detective work, honestly. So some of the examples of that were, so there's some layers. If you go to the elastic settlement solutions, there's some layers to the source of those documents, or those figures. Similarly in the radial drainage, and those are from Chapter 5 because that's one of the ones I worked on. Just had to really dig back to figure out who was the first person that actually put this out there in the geotechnical community. So that was really enjoyable on my part. And working with the team. I mean, it was a good team of people.
Excellent. All right. So I have a question that's like a process related question. So how did you decide what charts to include and what not to include? There's, a million papers out there and graphs all over the place. So how was that decision process?
I mean, I think that connects back to the legacy document feel. So we definitely started with the original documents. We didn't start completely from scratch in terms of we want to be aware of what was what people were used to and not completely just blow that up. And then, kind of chart by chart, or each author had some, latitude there to make decisions to take things out, to add things in. Most of us are pretty well connected to geotechnical practice. So I think we had the audience in mind there as well of what does the Navy or other tri-services engineer need? What do the practitioners need in this kind of a document? And then finally, I would have to say we had a few meetings along the way with the tri-services team. There's layers of comment periods within this that we had feedback from various sources as to, oh, you want to include this? Do we actually need this figure? And so on.
Great. Okay. Well, I think that pretty much wraps it up for us. I want to thank both of you for answering all of those questions. And I learned a whole lot. So I'll pass it back over to you, Brad.
Thanks, Andrea. Thanks, Dan. Thanks, Joe. You guys did a great job. We had fun. We got a lot of questions. Those are the hallmarks of a pretty good event. So for our viewers, thanks for joining us today, and thanks for chipping in with your questions and your opinions over in the chat. We really appreciate it. Like I said, that's what makes these things whole. You should have links in the chat, and we'll put these up in the notes underneath the video when it gets archived to the channel. And for a few of you in the chat, yes, this will be on the Geo-Institute YouTube channel until the end of time, or until YouTube does not exist, whichever comes first. You will always be able to find it there. We will put a link to download the manual in those notes underneath the video. And again, you can click that little GI logo that you see in the corner of your screen and click the subscribe button, click get notifications, and we will let you know every time we post something to the channel. So we hope to see you with us again on Monday for Terzagi Day. This will mark the 7th Terzagi Day, I believe. So we hope you're there with us. It's going to be a lot of fun. We have Geostrata Extra coming up later in October as well. You'll want to check that out. It's on rare geologic hazards. So thanks again to our viewers for sticking around. I hope you enjoyed what you saw today, and we will see everybody again soon.